finish off our two-part series on const, we will be talking about how const relates to parameters and returns. Const parameters are pretty straightforward. We like passing by reference because speed is good. We save a lot of time copying by simply creating another variable name. The problem is, sometimes the ability to modify the parameter is not. We can solve this pretty easily. We can just simply make our parameters const if we want to pass them by reference. This goes in line with what we talked about last video. In making our parameters const, we are making a promise to the client. Whoever uses this method is now guaranteed that the objects they put in will be the same coming out, even if they are passed by reference. Let's see that in action. For these examples, we'll be using the vector class, which I recommend looking at if you haven't seen already. It's a simple way to aggregate data, and you will see it a few times throughout 225. Let's first consider this helper method, printVector. It simply takes in a constant vector of integers and prints it out on a single line, each element separated by a space. Now obviously with a print method, as the name would suggest, we typically have no intention of changing our input data, but this const absolutely guarantees that nothing goes wrong. And considering encapsulation, our clients would likely not even see the implementation of printVector. Putting const is a guaranteed way to tell them their data is not changing. And the reason we pass this by reference in the first place is that this vector could contain millions of elements. By not copying, we save plenty of time and space. Now, here's a stranger method. When you get into more complicated methods, the temptation to modify the initial vector will be there, and sometimes it feels like the best choice. But due to implementation restrictions, you won't always have this luxury. And thankfully, even though this restriction may be tough to work around, const guarantees that you stay in line. If we ever try to ignore this const requirement, we'd be greeted with a common error. We'd be trying to write to a read-only variable. In other words, we'd be changing something we marked as constant. Const return types are a little harder to understand, but let's dive straight in. In this method, I create a vector of integers from an input integer. The method through which I do so isn't really that interesting. The point is that the const is in the signature. And in this helper method, I take a vector of integers and set all of its values to 0. If I try to create a vector and wipe it at the same time, I will be greeted with this large error. You will often see errors like this in 225, wherein you attempt to call a method on a variable and you will be told that your method doesn't exist. This is a textbook case of const errors. A constant integer and an integer are a different type. You may be able to set an integer equal to a constant integer, but ultimately they do have different type signatures, and therefore they are treated differently. This example will cement the role of const in a function signature. In this case, we create a vector from the secret vector method we talked about earlier, and then we clear the vector we created on a separate line. In this case, we do it all on the same line. This one works fine, and this one throws an error. Can anyone tell me why this happens?
Secret vector 1273 is constant, but code is not.
You're exactly right. It all comes down to types again. What we do in the first example is equate a vector of integers to a constant vector of integers, which is no different than equating an integer to a constant integer. It works one way but not the other. And then we call wipe vector on an integer vector, which is totally fine because that's what the method signature says. However, in the second case, we are effectively calling wipe vector on a constant vector of integers. As our method signature indicates, this is not okay. There is a type mismatch error that prevents us from using this method. In some cases, you will see const written before an operator equals implementation, and I thought it was important to go over why. Here's an example we've done before. As you can see, it has no const on the front. It would be stuck right around there if we used it. Without this const modifier, we are allowed to do some pretty strange things. For instance, this strange combination of operator equals is allowed, as well as something like this, wherein a method is called on the resolution of A equals B. Are these abilities inherently wrong? The answer is annoyingly, it depends. Whatever your client desires and whatever your implementation calls for, that's what you will use. There is no inherent right or wrong based on all situations. However, do know that in 225, you likely won't be dealing with this side of things. This goes a little far into the technical aspect, but it is something important to have a feel for.
Does the position of const matter in a method declaration?
Yeah, where we put const in a method signature has an impact. Here are a few things that can happen with a method creatively called method. We can have int const method, const int method, or int method const. Now, as we saw in the last video, the first two are effectively the same. They both have a return type of constant integer, or integer constant. It's just a syntax difference. The last one is entirely different. The method itself is constant. Let's say I have a class called example, which has method A, which is constant, and method B. Let's go ahead and declare two of those in our main. Example 1 and constant example 2. One of these 4 lines will throw an error. Which one do you think it is? Well, as I said in the first const video, const is not a power. It's a restriction. This means that we can rule out the first 2 options. Our const object should not be able to do something that our regular object cannot. And this next one requires a little bit of intuition, but it's not far-fetched to say that a constant object should be able to access a constant method. And that's the rule for constant methods and constant objects. Objects that are not constant have access to all of the methods within their own class. However, objects that are constant can only access the constant methods. This is another less common issue, but it is something that's good to know. Alright, that just about wraps up our section on const. We've gone over variables, pointers, methods, and parameters. All things that are fair game. As you tackle more advanced topics, it's a good thing to make sure these smaller things don't get in the way.